This is the 247 Prototype 2. It ejects the prints automatically, it has motorized doors, and it's mostly 3D printed. I designed the 247 4 years ago. I feel it's time to revisit and to evaluate this concept by modern standards. I'm Albert and you're watching 247 Printing. Let's do that! This video is not about selling anything. I want to show you what I made back then, and I'd like to hear your honest feedback. Please tell me in the comments. Some stuff you'll see is unsafe or just badly designed. Do not repeat this at home. You need a service for high quality 3D prints for your projects? PCBWay has got you covered. They offer professional 3D printing services for both plastic and metal parts. With a wide range of additive technologies like FDM, SLA, SLM, SLS and more, you can get your designs made quickly and precisely. Receiving a quote is more than easy. Just upload your file, choose the material and you'll get it instantly. Perfect for prototyping, but for production too. Check out PCBWay 3D printing services at PCBWay.com and bring your ideas to life. Save big on the PCBWay Christmas sale until December 31st. Link in the video description. When I started 3D printing in 2017, I made two mistakes. First was to get a slow, limited FlashForge Finder. Second, I said I wouldn't tweak printers, but of course I did. Over time I turned 6 finders into modified machines that fed a new obsession. Building conveyor systems for automated print ejection as I realized something. FDM printing already had amazing quality, but it was painfully slow for prototyping. So I tweaked those finders to my needs, including conveyors, and I eventually thought, why not design and build my own printer? A fully featured machine with a conveyor system for automation, but also a swappable print bed for big parts. The boldest part? I wanted the frame to be 3D printed. A crazy idea back then, but I wanted to try anyway. It would give me more control, artistic freedom, and independence from suppliers, except for the filament. In 2018 I built the 247 Prototype 0. Kind of a geometrical test fit and kind of a fail. I learned a ton though, and I wanted to see it functional. By 2019 I built Prototype 1, mostly 3D printed with a lot of waste mode parts, almost fully functional, and it worked so well it became one of my PLA and PTG workhorses. That was the motivation to push further. Fast forward to 2020 and I built Prototype 2. It introduced major upgrades. Automated doors, a modular enclosure, a way more refined design and additional features. That sounds like annoying marketing, right? Though, as I'll show, and as you'll see, there's still plenty of room for improvement. Let's dive in and explore the 247 Prototype 2 in detail. Core XY was the clear choice for the 247 right from the start. It's fast, it's scalable, and it keeps the XY motor stationary for better performance. I adapt the belt path from early versions of do-it-yourself designs like the Hypercube, keeping the XY turner simple and compact. In Prototype 2 I tried a vertical arrangement for the X-axis and toolhead. It seemed to work well for modularity and build simplicity, so that I'll probably stick with it in the next iteration. I chose precision shafts instead of linear rails. They are accurate, cost-effective, and perform well for the setup. But there's one challenge across the board. The weight of all of the moved parts. The X-axis and toolhead are heavier than ideal for a printer like that. I used the Hemera extruder as a starting point in 2020. Back then it was an exciting piece of hardware, but for a mostly 3D printed frame, the old Hemera is a worst case scenario. It's bulky and heavy, which limits print speeds. The toolhead itself was designed with modularity in mind. Swappable extruders, hot ends and cooling setups. Everything modern do-it-yourself printers feature today, and they do a way better job. The 3010 fan with that 4-way part cooling solution worked for the speeds of 6 years ago, but that's clearly outdated now and needs improvement for sure. For our next version, cooling must keep up with way higher print speeds. There are far better solutions today. Finally, bed probing. I used a BL Touch here and in a lot of other printers, and let's just say it gave me headaches. It's sensitive to temperature and electromagnetic interference, making it somewhat too unreliable for an automated printer like the 247. I've tried fixes like aluminium shielding and reworked the wiring a dozen times, but nozzle probing is likely the way forward. The print bed was always a core part of the 247's design. I wanted it to do two things: support a conveyor belt for automated print ejection and offer a swappable print bed for larger conventional prints. While the swappable bed took a backseat in Prototype 2, the conveyor system became the main feature. Conveyor belt printing is not new. MakerBot aggressively patented process and designs years ago. Creality's CR30 or the new Ideaformer use 45-degree printing. That's awesome for printing swords, props or long stuff in general, but I wanted regular 90-degree printing for versatile, high-quality results, being able to use our great conventional slicers. The challenge? Designing a reliable belt system. I experimented with a carbon fiber belt for durability and toolless tensioning, and it worked flawlessly at first, hundreds of ejections without adjustment. But after years of static load and temperature changes in the attic, it cracked. Making a new one for filming all the clips in this video taught me the assembly process needs improvement for precision and repeatability. Or we just get one from the shelf. Another issue is the ejection slide itself. It's not steep enough for small and/or lightweight parts to fall off cleanly. Fixing that and improving the tensioning system would be key in the next iteration. Currently, the conveyor bed offers a 160 by 160 print area, which is just enough to print every part of the 247. Imagine this: hitting print, and a few days later the printer ejects all of its own parts into a box. That vision isn't far off. For the future, I'm considering materials like PPACF for better strength and temperature resistance, and exploring solutions like even printing the belt and rollers. Yes, printing the belt. I did some experimenting on this and I still see some potential with modern strong materials. We should try that, as a continuous belt is needed. Or we just get one from the shelf. But that's boring, right? For a larger print area, upgrading to the common mini size of 180 by 180 makes a lot of sense, also considering nowadays print speeds, which enable for larger prints and shorter print times. The frame and enclosure of the 247 are almost entirely 3D printed. I designed the parts to be quick to assemble, with no need for squaring, measuring or calibrating like you'd see with aluminium extrusion frames. The parts align, also because of the threaded rods and easy interfacing, which means the entire frame build can be done in about 1 hour. One thing very important to me was aesthetics. From the front, back and the sides, you only see the nice outer perimeters, no visible fasteners. Yes, I think it's a great looking printer, but I'm curious, what do you think? Let me know in the comments. And be brutally honest, I need that. Another standout feature is the automated doors. For an enclosed automated printer like the 247, manual plastic strips weren't an option. I wanted real doors. These use those simple and cheap motors, making them reliable, low cost and frankly mesmerizing to watch opening and closing automatically. For our next version, I would simplify them further by scrapping unnecessary framing. The enclosure is modular too. The top cover is now an add-on, improving flexibility. Plus, there are clear panels everywhere, including on the head, because I want to see what the machine is doing. Anyone else feel the same? And speaking of enclosures, air filtration is crucial for me because I'm very sensitive to VOCs and fine particles. In Prototype 2 I had a makeshift solution. A 60-20 fan pulling air through a basic fleece filter. It worked a little, but honestly I wasn't satisfied. That's where today's sponsor, Voxel PLA, comes in. They've launched the X-Fitler, a solution compatible with the Bambulet X1 and P1 series and a perfect fit for the 247 project. On my Bambolab printers I previously used activated carbon combined with a bit of a fleece filter. The same we've seen on the 247. That may have helped a bit, but it was never truly satisfying to me when printing ABS. The X-Filter solves this problem in one affordable and efficient package. It features an HEPA 13 filter that captures 99.5% of the harmful particles. Plus, it has high surface activated carbon to neutralize fumes and VOCs directly at the source, before they escape the printer. For $5.99 or euros, you get a combined solution that supports you staying healthy while printing. And here's the best part for people from the USA. Voxel offers same-day and free shipping in the US if you order 5 or more X-filters. So if you print a lot of ASA, ABS or other toxic high-performance materials on your Bambolab printers, do yourself a favor. Stay safe, stay healthy and grab an X-filter at voxelpla.com. Recommended from my side. While the frame and its features worked even better than expected, also here there is a room for improvement. Repairs can mean annoying disassembly and threaded rods could be replaced with a faster, better or more convenient fastening system. But overall, the frame and enclosure provide function and modularity and they look pretty good while doing so. I also tried to get the build space heated by using a silicone heater on a metal plate, but that was neither efficient nor effective. Next up, let's talk about the electronics, because all this modularity and automation doesn't happen without the system behind the scenes. The electronics of the 247 are housed at the rear for easy access. At the center of it all is the MKS S-Gen board running SmoothieWare firmware. Back in 2017, SmoothieWare was a popular choice because it allowed easy firmware tweaks through a simple text file, no compiling required. It's not the most advanced system today, but at the time it did the job and already had the experience from the tweaked finders to work with it. The electronics of the 247 include a Raspberry Pi for enhanced control, powering the printer, and handling automation like the conveyor system and the doors. Speaking of those, the 2 conveyor motors at the bottom are configured as a second extruder, and the automated doors use an external driver for their motors. The WS1209 temperature controller is there to prevent overheating on the build space heating, because I didn't want the interfacing plastic parts of the frame to melt away. A cheap 12V 500W power supply is powering everything, with solid-state relays managing the print bed and enclosure heating. Oh, and there might be still a dead attic spider hanging out somewhere in there. Despite the wiring mess back there, the electronics worked reliably, but they would need a major upgrade for the next version. Modernized at reduced complexity, safe and ready for fast printing. Here I use Octoprint, and it remains an essential enabler for the 247. Octoprint's user interface and extensive plugin repository are unmatched, even compared to modern Clipper UIs like Mainsail or Fluid. Make sure to support Gina, the creator of Octoprint, if you use Octoprint regularly. Sure, you can code your own Clipper macros for everything, but not everyone has the time or skills for that. 2 plugins stand out: the Continuous Print plugin and the WS2812 RGB LED plugin. Continuous Print allows serial printing and print queue management, essential for automation. It's not the most intuitive at first, but it's quite powerful once set up. And those RGB LEDs? They are more than just eye candy. The LED strip at the front of the 247 gives real-time feedback. This is how I set it up. Print progress, idle state, connection Octoprint to mainboard established after startup, connection Octoprint to mainboard interrupted, print or print queue successful, print cancelled or general error. My partner thought it was a useless gimmick at first, just like underbody lighting at cars, but over time it has proven too useful to ignore. That said, I totally want to move the 247 to Clipper for a significant speed boost. Can't wait to see those input shaper graphs on that heavy X-axis on a printed frame. I still want to use Octoprint alongside Clipper because of its essential plugins. Right now the 247 prints at 80 to 140 mm per second with accelerations up to 3000 mm per second squared. Not too bad, but you can see the ringing in the prints. That's the result of combining a heavy toolhead, a cantilevered bed and a 3D printed frame. To fix this, the next version would need lighter moved parts on the X and Y axis, a triple supported Z axis like on the Trident or Bambolab machines, and a redesigned frame for better stiffness and rigidity in all key areas. Combine those upgrades with Clipper's input shaping and we'd see a huge boost in performance. Can we match Voron or Bambolab speeds? I don't know yet, but that's something I'd love to explore. The materials used for printing the 247 also play a huge role. I mean, imagine a frame printed from high-end carbon fiber filament instead of PETG like on Prototype 2. Trying new geometry, materials and print settings could unlock a lot of potential, and that's something I'm excited to try in the future. Back when I printed the 247, mostly out of PETG, it took about 120 hours with a 0.6mm nozzle at speeds of 40 to 50 mm per second, without the enclosure. But today, with affordable high-speed printers and modern high-flow materials, that print time could be cut in half while achieving even better quality. The frame part connections also need attention. Improving how the parts are fastened would make assembly easier, increase rigidity, and improve overall alignment. The conveyor system is another area for improvement. I'd extend the printable area to 180 by 180, improve belt tension, and update the rollers. A continuous belt would solve a lot of current issues. For certain aspects, Creality CR30 is a great example of how to do it right. Big thanks to Creality and a shout out to Chris Deng for providing a sample machine for me to check out. Also have a look at their new K2 Plus. It looks like exactly what the K1 Max should have been. Some of you might remember my review. Did you notice how often I said would throughout this video? I would improve this, I would redesign that. But here's the thing, the 247 is an exciting project and I see a ton of potential. If there's enough interest and feedback from you, this community, I might just go all in on a release-ready iteration. Judging from my experience on that project, that's a big step. It would mean another refined design, a lot of testing, setting up hardware kits and top-tier documentation. If you want to see the 247 go further, show your support. Like this video, share it with others who might care, and subscribe to 247 Printing. And if you want to help make this project a reality faster, consider supporting me on Patreon. So, what do you think? Let me know in the comments. Thanks for watching, servus und goodbye!